Welcome to the class. And today we're going to learn the third model of combinations. So first of all, let me introduce you a question that is related to the third model. The question is, suppose we have a large collection of undistinct elements, and our task is to assign them to R different small collections. And the size of the small collections are N1, N2, N3, etc. until Nr. And note that sum of N1, N2, and Nr is N. And the question is, in how many ways we can do this task, or how many different possible assignments? Clear? Task is to assign a large group into several small groups. Okay, I'll give you 3 minutes to think about this question. And I'll give you a hint. The hint is to use rule of product. So first of all, you can calculate how many steps are involved in this task, and how many ways you can complete the first task, and how many ways you can complete the second task, and etc., right? Okay, I'll give you 3 minutes to think about this question. All right, any ideas? Okay, so to complete this task, let's say we have n different elements in the large group, right? And the task is to assign these elements into different small groups. And the size of the small groups are n1, n2, nr. There are small groups, okay? And R is and we also know that n1 plus n2 plus nr is n. Okay, so how many steps in total to complete this task? There are steps, right? So for the first step, how many number of ways we can complete the first step? The first step is to choose n1 out of n, right? So there are n1 number of ways to complete the first step, right? So how about the second step? The second step is to choose n2 from the remaining n minus n1 elements, right? So this is the number of ways we can complete the second step. Because here we're going to use the rule of product, we need to multiply these numbers together, right? How about the second one? The second step, we need to choose the n3 out of the n minus n1 minus n2, right? Okay, so in the same way, how about second to the last step? How many different choices are there? We need to choose n r minus 1 out of the n minus 1, n minus n1 minus n2, etc., and minus n r minus 2 number of different elements, right? Okay, so how about the last one? Last one, we need to choose n r out of the n minus n1 minus n2 minus n r minus 1 number of different elements, right? Okay, so now let's expand each term to see if we can cancel any terms there. Okay, so according to the combinations formula, the first one, Cnn1 is n factorial over n minus n1 factorial and n1 factorial, right? So how about the second term? Second term is n minus n1 factorial over n minus n1 minus n2 factorial and n2 factorial, right? Okay, third term is n minus n1 minus n2 factorial over n minus n1 minus n2 minus n3 factorial and n3 factorial, right? And second to last term is n minus n1 minus n2, etc., minus nr minus 2 factorial over n minus n1 minus n2 minus n r minus 1 factorial times n r minus 1 factorial. Okay, so how about the last term? Last term is n minus n1 minus n2 minus n r minus 1 factorial over n minus n1 minus n2, etc., minus n r factorial and times n r factorial, right? Okay, now let's have a look at if we can cancel any of the terms here. Of course we can, right? Well, the first one and second one, we can cancel these. And for the second one and third term, we can cancel these. So basically, for any terms in between, it can be canceled with next term, right? So basically, these are all canceled. This has been canceled, and this has been canceled with this one, right? Okay, note that here n minus n1 minus n2 and minus nr is actually 0, right? Because the sum of n1 to nr is n. So this is a 0 factorial, which is 1, right? Okay, so the final result is n factorial over n1 factorial, n2 factorial, etc. and r factorial, right? This is our final result. So now let's make a summary. The takeaway is if we want to assign n different elements in a large collection into different small collection, and sizes of the small collections equals size of the larger collection. Total number of ways we can do this task is n factorial over n1 factorial, n2 factorial until nr factorial. n1, n2, nr are the sizes of the small collections. Okay, please write this conclusion down onto your notebook, and we're going to use it to solve some real-world problems. Okay, note that r should be greater than or equal to 1 and less than or equal to n, right? Okay, any questions here? No? All right, let's see some examples. First of all, I'll lead you solve the first question and leave the rest of the questions for you to solve, okay? The first one, a police department in a small city consists of 10 officers. If the department policy is to have 5 of the officers patrolling the streets, 2 of the officers working full-time at the station, and 3 of the officers on reserve at the station, how many different divisions of the 10 officers into the 3 groups are possible? Okay, so in this question, the task is, okay, in a large group, we have 10 officers, right? And the task is to assign these 10 different officers into 3 small groups. First group is to patrolling the street. Size of this group is 5, and next small group is working full-time at the station, which has a size 2. And the third small group is on reserve at the station, and the size is 3, right? So the task is to assign from a large group into several small groups. Note that the sizes of the small groups, 5 plus 2 plus 3 equals the size of the large group, right? So we can use the third model of combinations to write total number of ways directly. 10 factorial over 5 factorial times 2 factorial times 3 factorial. This is the total number of ways, right? Okay, and the final result is 2520. Okay, have a look at this. Any questions? No? Okay, let's see the next one. 10 children are to be divided into a A team and a B team of 5 each. A team will play in one league and B team in another. How many different divisions are possible? Okay, I'll leave you 5 minutes for you to solve this question. Okay, have you finished? What is the solution here? Okay, again, this is to assign a large group into two different small groups, right? So the total number of ways we can do this is 10 factorial over factorial 5 factorial times 5 factorial, right? Total number of ways is 252. Okay, any questions? No? All right, let's make a brief summary of what we have learned today and for the previous days. So we have learned 8 common counting techniques, right? First is called rule of product. That means if you complete a task and the task involves several steps, total number of ways to complete the task is n1 times n2 times nk, right? For k steps. And second is called rule of sum. That means if you complete the task and the task, you can complete task in several different routes. And in each route, you have several different ways. And in this case, you need to add all these numbers together, right? This is called rule of sum. And third model is permutations without replacement, right? That means if we have n distinct elements in a group and we choose R out of the n and line them up in an order. Total number of ways we can do this is Pnr, which equals n factorial over n minus r factorial. Next is called permutations with replacement. That means we choose r out of n, and for each choose we replace the collection is same elements, align them in an order. Total number of ways to do this is n raised to the r's order, right? Next is to do full permutations. On a multi-set. Total number of ways to do this is n factorial over n1 factorial times n2 factorial times nr factorial. Note that the sum of n1, n2, and nr is n. And n1 is number of identical elements for the first kind. N2 is total number of identical elements for the second kind, and nr is total number of identical elements for the rth kind, right? And 6 is combinations without replacement. That is to choose r out of n, and this time we do not line them up in an order. The total number of ways to do this is CNR, which means n factorial over n minus r factorial times r factorial. Seventh model is to choose r out of n, and for each choose, we replace the original group with the same elements. In this case, total number of ways to complete this task is Cn plus r minus 1 r. Okay, and eighth model is the model we have learned today, is to assign from a large group to several small groups, right? So for the small groups, their size is n1, n2, n3, and nr. Note that n1 plus n2 plus nr is n. And there are n factorial over n1 factorial times n2 factorial times nr factorial number of ways to complete this task, right? And also n1 plus n2 plus nr is n, and r is greater than or equal to 1, or and is less than or equal to n. Okay, so these are the common counting techniques we have learned so far in this chapter. Do you have any questions? Okay, next we're gonna use these counting techniques to solve some probability problems. Okay, note that for an event A, let A be an event, S be the sample space. The theoretical probability of event A is denoted by PA, right? And PA equals number of sample points in A divided by the number of sample points in the sample space. And we can use common counting techniques to calculate numerator and denominator respectively, right? Okay, so now let's have a look at some concrete examples. First, let's have a look at this question. 6 girls and 5 boys wish to join a committee. 4 of them will be selected. What is the probability that 3 girls and 1 boy will be selected? Okay, so what is this task? Task is to choose some people out of a group of people, right? In this group, we have 6 girls and 5 boys, and the task is to choose 4 of them. And we want to calculate the probability that 3 girls and 1 boy will be selected. So first of all, we need to know how many number of ways we can complete this task, right? And use this number denoted by the total number of ways we can complete the task. That is the probability of this event, right? Okay, so we choose 4 of them. 3 girls plus 1 boy. How many ways we can do this? This is a 2-step task, right? First step is to choose 3 girls out of 6. Second step is to choose 1 boy out of 5, right? So this is the number of ways in this event. How about the sample space? Sample space task is to choose 4 out of the 11, right? So this is the total number of ways in the sample space. And if you want to find the probability of this event, suppose this is event A, if you want to find the probability of this event, you need to use the total number of sample points in this event over the total number of sample points in the sample space, right? And this is approximately 0.303. Okay, please have a look at this. Any questions? No? Okay, let's do another example. Okay, let's see this example. 4 different numbers are selected at random from 1 to 15. What are the odds in favor of exactly 2 of the numbers being divisible by 5? Okay, so this is the event of interest, right? So let's denote it as a letter A. Here you want to find odds in favor of A, right? Odds in favor of A. Okay, remember what is odds in favor of A? Odds in favor of A is defined as the probability of A over the probability of A's complementary, right? So you need to calculate this two probability. Okay, I'll leave 5 minutes for you to solve this question. Okay, have you finished? So we need to calculate the probability of this event A, right? This equals the total number of ways in event A divided by the total number of sample points in the sample space. Okay, so how many ways can we finish event A? How many ways we can finish this task? There are two steps, right? First is to pick two numbers that is divisible by 5. That means we pick 2 from, so how many numbers can be divisible by 5? 5, 10, 15, right? These three numbers from 1 to 15 are divisible by 5. First step is to choose 2 from these 3. And second step is to choose the remaining 2 from the remaining 12, right? Okay, so how about the sample space? Sample space is simply how many total number of ways we can complete the task. Complete the task is to choose 4 from the 15, right? Okay, so this is the probability of this event, which is 0.1451. So the probability of a complementary is, of course, 1 minus 0.1451, which is 0.8549, right? Okay, so odds in favor of A is 0.1451 over 0.8549, which is approximately 0.1697. Okay, any questions? No? Okay, so this is the end of today's lecture slides. And the rest of the time is for you to complete today's homework, okay?